Hello everyone, welcome to my channel. In this video, I will explain about Isomap. Okay, so this concept belongs to machine learning. Isomap is the isometric mapping. So what is the full form of Isomap? It is nothing but isometric mapping. So let us see the definition. Isomap is a technique. It is used to reduce the high dimensional data into fewer dimensionals while keeping the original curved shape of the data intact. Okay, so what is the meaning of Isomap? It is used to reduce the high dimensional data into fewer dimensionals. Okay, so the large data is divided, the large data is reduced into smaller data, and while keeping the original curve. Okay, so it should not reflect the main applications. So this is called as what we say Isomap. You see here, what is the use of this Isomap? Isomap is useful for non-linear data. Remember all of you? So we'll use this Isomap in non-linear data. So we'll see the algorithm now. In the algorithm, it contains completely 6 steps are there. So what is the first step? First step is the find the nearest neighbors, and second one is the build neighborhood graph, and third one is the calculate edge distance, fourth one is the find shortest path, and fifth one is the create distance matrix, and last one is the apply MDS for dimensionality reduction. Okay, so these are called as steps in Isomap. In order to better understand, we'll go with the problem. Okay, so you observe example problem on the screen. So what will be happen? Apply Isomap algorithm for following data. So some data points has been given. A is equal to 1, 1, B is equal to 3, 1, C is equal to 6, 1, D is equal to 6, 3, E is equal to 10, 3. So what is the value of k? K is equal to k, nothing but here the nearest neighbor value is 2. So take the nearest neighbors and construct Isomap. So okay, so you observe in the algorithm, what is the first step? The algorithm first step is find the nearest neighbors. So what is the meaning of nearest neighbors? So in the given data A, B, C, D, E. So in order to find the nearest neighbors, we'll use one formula. The formula is called as square root of x2 minus x1 whole square plus square root of y2 minus y1 whole square. Okay, so this is whole square x2 minus x1 whole square plus y2 minus y1 whole square. So remember, when you find the nearest neighbors, what we have to do? So we need to find out the nearest neighbor of A first, then we go for B, then you go for C, then we go for D, then we go for E. So when we find the A, remember all of you, the distance something like A to B, A to C, A to D, and A to E. So when we talk about A to B, so what is the value of A? A is here 1, 1, B is 3, 1. So A is 1, 1, B is 3, 1. So the A value is x1, y1, and this B value is x2, y2. So x1, y1 is 1, 1, x2, y2 is 3, 1. So we'll substitute the x1, y1, x2, y2 values here. So you observe 3 minus 1 whole square plus 1 minus 1 whole square. So this is equal to 2. So similarly, we'll find A to C, A to D, A to E. So when you observe A to E, so what is the value of A? A here 1, 1, E here 10, 3. So 10 minus 1 whole square plus 3 minus 1 whole square. So when we perform all this, we'll get all the details like this. Okay, so these all are distance point A. Now out of all these, we need to select the which one. So please remember all of you, in the given question they mentioned the value of k is 2. So when the k is 2, you need to take top 2 smallest values. So in this, the answers are 2, 5, square root of 29, square root of 85. So out of all these, the smallest values are 2 and 5. Hence we have to write the answer is A to B, A to C. How to write? By merging these A to B comma C. This is about the point A. But when it comes to point B, so what will be happened from the point B? Again we need to calculate B to A, B to C, B to D and B to E also. So when it comes to B to A, so B to A, 3 minus 1 whole square, 1 minus 1 whole square, this is 2. B to C, this B to C, 3 minus 6 whole square, 1 minus 1 whole square, this is 3. And B to D, the value are square root of 13, and B to E, the value is square root of 53. Now the value of k is 2. We need to find out the minimum 2 values. The minimum values are 2 and 3 out of all these 4. Okay, so now for this B, the distance is B tends to A, B tends to C. So how to combine these two? B tends to AC. Similarly, we can do for C also. So for this C, what we can write? So we can write the answer is like distance is C to A, C to B, C to D and C to E. So we need to do the values between C and A, C and B, C and D, C and E. So this is the values of C is 6, 1. So you observe 6, 1, A is 1, 1. So 6 minus 1, 1 minus 1 for this CA. For this CB, 6 minus 3, 1 minus 1. For this CD, 6 minus 6, 1 minus 3. You observe CD, 6 minus 6, 3 minus 1. So this is about the point C. So the values are 5, 3, 2, 4. So out of 5, 3, 2, 4, which are minimum? The minimum values are, first one is the 2 and second one is the 3. So the distance is C to B, C to D. So the answer is C tends to B comma D. So these two are called as nearest values. Again we need to find out the similarly for D also. So when we find the D, we'll get all the values of this one, and in this the minimum values are 2, 4. So that is D tends to CE. And for E, we'll find all the values. So we received all these values, and the final distance of E is E tends to DC, because the minimum values are here this 4 and square root of 20. So that is E tends to a small value is here D first. That's why we have written D first, then C. So we completed step 1. So we find all the values of A to B, A to C, A to D, A to E, B to A, B to C, so on. Okay. Now we go for step 2. Okay. So in the step 2, we need to build a neighborhood graph. Okay. So how to draw this graph? You observe here how to draw this graph. So first one is the A tends to BC. So first we will write here A tends to BC. That is A tends to B and B tends to C. Okay. So this is about the first one. But when it comes to B, this is equal to B tends to AC. So B tends to, already A is there, B tends to C is there, no problem. So this is about the B. But when it comes to C, C is B comma D. So C is, B is there already. So you write D. When it comes to D, D is CE. So D is already E is there, C is there. We write E. And what is this E? E is the D comma C. Okay. So in this, the values are for E, that is E comma C. E comma C. So this is called as a neighborhood graph. So for E, there are two values are there. So first one is the D, second one is the C. So that's why, so this is the final graph regarding this values. Okay, from this values only we have built this neighborhood graph. Now you see in the step 3, so actually there are completely 6 steps are there. So we need to find out the, in the step 3 we need to find out the calculate edge distance. So how to find out the edge distance? Just you take here the values of A to B, B to C, C to D and D to E. So these are called as a edge distance. So here if we find the edge distance of this one, what is going to be happened here? So the edge distance could be here okay. So you observe where we need to find out the edge distance. So when we find out the edge distance, what is the answer here? So you see in this d of x comma y is equal to square root of x2 minus x1 whole square plus y2 minus y1 whole square. So what is going to be happened? The x2 minus this one 3 minus 1 1 minus 1 because of this is x1 y1, this is x2 y2. So the answer is 2. Now BC. So what is the value of BC? BC is 3, CD is 2, DE is 4. So how this DE is 4? DE. So you observe 10 minus 6, this is 10 minus 6 is 4 square and 3 minus 3 is 0. So 4 square means the answer is 4. So this is a way to find out the edge distance. So A to B, B to C and D to A. Okay. So now here A to B, B to C, C to D, D to E. These edges. A to B, B to C, C to D, D to E, E to C. So we'll also find here E to C. So how to find this E to C? This is E and C. This is equal to EC. So what is the value of E? E values are 10 minus 6, 3 minus 1. 10 minus 6 whole square plus, so this is E to C, 3 minus 1 whole square. So the answer is here. This is equal to square root of 4 square plus 4 square plus this is 2 square. 2 square means 4. So this is equal to square root of, so 4 square plus 2 square. So this is 16 plus 4. This is equal to 20. So we will find out the value of even EC also. So what is EC? 10 minus 6, 4 square plus 3 minus 1, 2 square. So 16 plus 4, this is equal to 20. So this is about the EC. So now we will find the value of geodesic shortest path. So we will find out the value from the path A, path B, path C and path D and even path E also we need to find out. So how to find out these values? So from path A, we are going to take the value as A to B, then A to C, A to D, A to E. So we'll take the value of B, B to A, B, D, C, C to A, B, D, E, and from D, we'll take all this A, B, C, E, and we'll from E, A, B, C, D. Now remember all of you, when you perform this A, what you have to do? You need to take the value of this A to B. So what is the value of A to B? A to B value is here 2. So directly you write this 2 value here. So this value. So we'll write 2 here as it is. So this is 2. But when you find the A to C, this is we need to write as A to B, B to C. So this is equal to AB plus BC. So what is the value of AB? AB is 2, BC is 3. This is equal to 2 plus 3. This is equal to 5. But when it comes to A to D, how to write this A to D? This is A to B, B to C, C to D. So the answer is A plus B, AB plus BC plus CD. Yes, how to find out A to A, B, C, this A to D? So you observe here, when you have A to D, so what you have to do? We need to do so A to D. Yes, this A to here, A to D. So this is A to B plus B to C plus C to D. Yes, so this is A to D. This is equal to A to B, B to C, D. So how to write this one? We can add AB once, we can add BC once, we can add CD. So this is called as a 5. This value is 7. But when you find the A to E, A, B, C, D, E. So how to find out this A, B, C, D, E? AB plus BC plus CD plus DE. Yes. So how these values we have? Already we have the values, we find the values there already in the above. AB is 2, BC is 3, CD is 2, DE is 4. You observe here, DE is 4. Okay. So this is a way to find out the compute geodesic or shortest path distance for A. So similarly, we can also perform B. So what is B? BA is 2, BC is 3, BD. How to find out this BD? BD means here, this place. Okay. So how to find out this BD? So you observe here, when I say B to D, so this is B to C, this point. So when I say B to D, so this is B to C. I want to go from here to here. So the answer is B to C plus C to D. Yes. So this is B to C plus B to this one, B to D. So how to find out this B, C, D? So the answer is BC plus CD. So similarly, we find all the values for C and D also. So we can find E also even. Okay. So when you find all the values, after completion of this one, we will find out the geodesic distance matrix. So remember all of you how to write this one. So when I say A to A, please remember all of you, this is 0. B to B, this is 0. C to C, this is 0. C to D, D to D, this is 0. E to E, this is 0, because there are no more elements for A to A, B to B, so on. But when I say A to B, how this value came? This is 2, A to C 5, 7, 11. So 2, 5, 7, 11. So you observe when you find out the A to D value. So this is actually geodesic shortest path distances. 2, 5, 7, 11. Yes, you write all the values in sequence. B value 20359. So B value this one 20359. Yes. C value 5326. So C value 5326. So middle value is missing, because when I say CC, that is 0. AA is also 0. E, from E, what we can write? We can write 11, 9, 6, 4. Okay, so 11, 9, 6, 4. So this is called as geodesic distance matrix. So after completion of this one, we need to apply MDS. Okay, so when we apply MDS, apply classical multidimensional scaling. So remember, when you say MDS, this is nothing but multidimensional scaling on geodesic matrix based on step 5. So MDS converts the distance matrix into low level coordinates. Important point. While preserving the shortest path. So remember, we received this graph, this matrix. So when you receive this matrix, now we need to find out now we need to apply the multidimensional scaling. So when you apply multidimensional scaling, please focus on low dimensional coordinates. So what are the low dimensional coordinates? So remember all of you, actually in this, the low dimensional coordinates are this one. So this is equal to the value of final, this one is after applying MDS, the A is 0, B value is 2, and C of A is 5, and this is 7, this is 11. Actually this is called as a single dimensional matrix. Now you observe, so this is called as final first one dimensional embedded obtained. So for the given coordinates, okay, so this is the final answer. So actually they have given in the question the different elements. The elements are, you can observe on the screen, the elements are that is A is equal to 1 comma 1, B is equal to 3 comma 1, these values. Actually these are the given points, but what is the final optimized answer after using this concept? So the final answer is we received right now. So you can observe on the screen. So this is the final reduced coordinates. Okay, so this is about the concept called as Isomap. So this is nothing but isometric mapping. So very simple. Okay, so thank you for watching this video. Please subscribe my channel. Thank you one and all.